let's put that welcome screen up and let me say thank you and welcome to the Clean Code for Python webinar, or how Python can be really weird. We are so excited to have a great speaker today, and we will demonstrate to you the importance of clean code, demonstrate and help you discover how Python can behave unintuitively, and also understand how Sonar Lint and Sonar Cloud fit into the picture. So I would like to introduce myself. My name is Andrew, and I'll be the moderator for this webinar, which will be presented by Nafiul Islam. Before we start, just a couple of quick housekeeping points. So the session will last 30 minutes. There'll be a Q&A at the end, and you are invited to submit your questions throughout the webinar using the Q&A box in Zoom. So not the chat box, the Q&A box. We have two panelists who will be attempting to answer your questions live during the webinar. They are Stefan van der Werf and Michael Budzowski from our support engineering team. So they will get to as many of your questions as we can. We will record the session and we will send out a link to the recording afterwards. Finally, at the end of the webinar, a short survey will pop up. Your feedback is a gift, so thank you for helping us improve. So without further ado, Nafiul Islam. Nafiul has been programming since he was 14. He has a decade of software experience and is adept in Python and exploring Rust. He authored Mastering PyCharm. Nafiul has spoken at global Python conferences and held positions at JetBrains and Microsoft. And in his free time, he loves reading fantasy novels. And you can see where you can follow him there on Twitter. Nafiul, over to you.
Hey, everybody. Thank you very much for coming to this webinar. This webinar is really about clean code for Python and how Python can behave in unexpected ways. So before we get into that, let's talk a little bit about what is clean code. So in a nutshell, for me at least, clean code is about having a sustainable code base. It is a code base that you can get a lot of mileage out of. If your code base is something that you're afraid of using or constantly goes down, or you need a lot of time to understand what is going on, that isn't very sustainable for your developers. So it can get very, very difficult to work on non-sustainable code bases, especially with code bases that are not clean. Clear code is also explicit. I think one of the maxims in Python is, explicit is better than implicit. And clear code is about making sure that there isn't a lot of ambiguity in what you're writing. It does what it says and says what it does. And consistent in terms of conventions. So, not mixing your snake case and your camel case, just being consistent about variable names, consistent about class names, consistent about function names, etc. And also how you deal with modules in Python. And lastly, it is fit for production. That means your code runs and there aren't a lot of bugs in it. You're not going to get lots of memory leaks as well, things like that. So what does clean code exactly mean in Python? Well, Python has been famous for, having very clean and consistent syntax. So it is about what we call idiomatic Python. It is about following PEP 8, which is the style guide, and, avoiding bad coding patterns that can cause bugs. And of course, last but not least, following security best practices. But, why would you want this? Because if you don't have clean code, what you're building up is technical debt. And technical debt isn't good for you. This is an example of a function that is importing things within the function definition. And ultimately, the only thing that this does is give you a product of a bunch of numbers. So this is confusing. There are so many easier ways to do this. Now, I know this example is contrived, but you'll find a lot of places, a lot of popular projects use very complicated code. They use locals and globals everywhere. So it's quite difficult to understand. So technical debt slows you down because it takes longer to understand what, say, a particular piece of code does. Even sometimes it can be your own code. And technical debt is expensive. you need a lot of man hours. So ultimately, it's not good for you. So how do we get clean code? At Sonar, we have a way of a methodology, if you will, that is called clean as you code. What that means is that instead of handling the entirety of your technical debt in one go, because that's difficult, and some parts of your code base, it's esoteric for a reason. Sometimes you're, sub-processing very old shell scripts or something like that, and it can often be difficult to refactor that. So we have this methodology called clean as you code. And that basically means that as you change the files in your code base, you also use tools to help you prevent writing bad code in the first place, but also fixing any bad code that you might have to look at or that is a part of your commit. So you might say at this point in time, and going back to the title is how Python can be read. You might say like, well, I follow all the conventions. My code is great. Well, at times Python can behave a little weird. There might be some unintentional ways in which Python behaves that makes it very confusing for people to understand. And sometimes it doesn't behave the way that you expect. Hopefully, that is what I'm going to be showing you. Now, going back to this was a study done by the SEI Institute, so the Software Engineering Institute at Carnegie Mellon. And they actually pointed out that a lot of the code, a lot of the reasons for technical debt is code. So overly complex code, code duplication, dependencies on external people's code, and of course, obsolete code. So before I jump into explaining how our methodology works, how the clean as you code methodology works, I'd just like to ask you a question. You have code that you're dealing with. What do you use to analyze your code as you write? So the poll is up. I'm going to give you a little bit of time, then we're going to see what people use. Okay, so the vast majority of you use PyLint, and a lot of you use SonarLint. Some of you use Rough, and as a style checker, some of you use Black. That's great. A lot of people use different things. So I'm going to show you how SonarLint works in this example. And more than SonarLint, I'm going to show you how Python can behave in very unintuitive ways. So I'm going to fire up PyCharm over here. I hope everybody can see my code base, and I just want to point your attention to a couple of things. First of all, I do have SonarLint installed, and if you don't have SonarLint installed, you can go to plugins over here, and you can see that I have SonarLint installed. But if you don't have it installed, you can type in Sonar. You'll see SonarLint. It's the one with a 5.6 million downloads, so it's well used. And we're going to be using that in these examples. So, okay, without much further ado, no weird Python talk or no gotcha talk in Python can start without mutable arguments. So here we have a function that takes an item, adds it to a new list, and then returns puts that item in the list and then returns that list. So here we have v, which is just a variable over here. We're going to say we're going to add this to v, and then we're going to add a couple of items along the way. Now, here's the thing. This is a different function call. This is another function call, and this is another function call. These are all different function calls, so they should be creating new lists for us. But if we were to run this, you're going to see that V has a lot of interesting things happening to it, because over time, more and more items are being added to the same list. So if we go up over here, we can see what's going on. You want to change the default value to none and initialize this parameter inside the function or method. Why? Because every single time we aren't giving it a new list, it is using a reference to the same list that we put here. This is why you're constantly getting things added to the same list over and over again. So let's do that. Let's just set this to none. If items is none, items is equal to a new list. And let's see if that works the way that we expected it to. So there we go. V has one item added to it, and these all have their own separate lists. So this way, you can prevent yourself from shooting yourself in the foot. And this isn't just about lists. It can also be, if we get rid of this, it can also be a dictionary. It can also be a set. So anything that is essentially kind of like a reference to a container type is susceptible to this problem. Now, another thing Sonar Lint does for you is that when you have these kinds of common problems, of course, it highlights it, right? And you can, of course, see what your problems are. So here, change the default to none, and this gives you the exact rule that you want to be talking about. So if you take a look at these are very exhaustive documentation on the different rules that we have. And you can see, like it says, set, dict, and list are susceptible to this, but also collections module, DQ, chain map, counter. I love this object. And default dict as well, which is something I use quite a lot. So it not only tells you, hey, you might not want what is actually going to happen in this code to happen, and this is why. But sometimes it actually goes a step further, which is that it can give you a way to fix this for you. So if you're using PyCharm or if you're using VS Code, this works as well. But you can hit Alt-Enter or whatever you use to invoke your quick fix, and you can say, hey, fix that code for me, please. I don't want to do it myself. I'd like use Sonar Lint to do it for me, and just goes and does it, which is great. So that's one of the ways in which Sonar Lint can really help you. Another way, and these things are not intuitive. So a lot of the times when you're working with code, you might say, like, look, I don't write bad code. I don't do this. A lot of the things that we're going to discuss, aren't exactly intuitive. And they might be, you might be like, wow, I didn't know this, or I didn't expect that. Another one that people often talk about is called integer caching. And what that essentially is that Python caches the integers between -5 and 256, positive 256. So what that means is that when you say a is equal to 1 or a is equal to 2 or whatever, that number, because it's small, it always refers to the same object. A new object is not created. That's what everybody knows, and that's common knowledge. But we're going to see something interesting here. So here I have a bad idea. I just named it that. It's not a good idea. And you print, we want to see the value of this, and then 999. We also want to see the value of this. So if you take a look at this, both this should be true, and this should be false, right? Because of the integer cache. But see what happens. Both are true. Both are true. Because the is operator is comparing the reference to A to B. So it is always the same object. It's always the same object. But, the integer cache is from -5 to 256. So why is this happening? Well, what happens is when you have declarations within the same Python file, this doesn't count because it's part of the same compilation unit. So ultimately, it just goes into the same PYC file. And therefore, these objects point to the same thing. So you might say the only places that you can see this is different is in the console. Over here, if you do A is equal to 10, B is equal to 10, and if you do A is B, you get true. If you do C is equal to 999, D is equal to 999, you do C is D, oops, sorry, C is D, you're going to get false. But you might say, you know, I don't, this is fine. I don't really use the console to write production code. Why should I care? Well, if we were to import C and D, so from utils, import C and D, and of course, these are also values 999. I can just go over there. You can see A, B, C, and D. They're 999. If I come back and if I comment these out, if I were to run it, oops, sorry, this will be fine. If I were to comment these out, see what happens. Well, I guess it's a part of the same compilation unit, but in general, when you have a situation like this, why? Let me just. Well, this is interesting. I think the PyCache file hasn't been cleared, and that's why you're getting a situation like this. But in general, what you don't want to do is use the is operator, because it doesn't actually compare the identities. They actually compare the reference. So you always want to replace this with a double equals. So if you were to run this, that would be true. You're just going to try this again. Import A, B, C, and D. And to comment this out. See if that works. Yes, that is true. If I do an is over here, is over here, I don't know why this is working the way it is, but essentially, this is not reliable if you're copying if you're importing something from a module. So that is integer caching in a nutshell. Another thing that I think stumps a lot of people is something called late binding closures. Now, late binding closures are basically things where the final value of something outside the scope of your function remains the same. So here we're trying to generate the 3 times table. And if you were to run this, we get nothing but 27s, which is kind of odd if you ask me, because ultimately what we're trying to do is generate the 3 times table, or 4. If we run this again, or 5. So that's pretty weird. But if we wanted to make sure that this value, the value of I, is what ranges, and if we take a look here, add a parameter to the function multiplier and use variable I as the default value. So if we were to change this and say I is equal to I, you're going to see SonarLint no longer complains about that, and we get the correct times table for this. So what was previously happening is that the last value for this for loop was getting plugged into the value of I, because it's from the outer scope, and it wasn't changing. So that is a problem. And this problem extends to lambdas as well. So if you were to take this out and say, for I in range 10, you say lambda x, I times x. Oops, there we go. You're going to run into the same problem. But if you were to set the default answer I is equal to I, which you can also do in a lambda, you see that this is no longer the way, this is what we expect. It goes from 5 times 0 all the way to 5 times 9. So that's another thing that that I don't think is intuitive in most cases, because it's very easy to step into this mistake. And if you take a look here, if we didn't have this, we have SonarLint reminding us that, hey, you might want to make this a default argument. So these might all be things that you've already been accustomed to, things that you're used to. But here's another one. And this is not something that we catch exactly right now, which is that which is the new match case statement. So here we have a match test, which basically is trying to see if there is an empty list, if there is one item in a list, two items in a list, or if it's something else. Now, I want you to look at this. So here we match the sequence. We can pass in a list. We can pass in a set. We can pass in a list. We can pass in a dictionary or anything, any kind of sequence, really. But in this particular case, we're going to be using a list or tuple. Actually, we're using a tuple. So here, if you take a look, if it's empty, we get something. If there's one item in the list, we bind one of the values, the first value. If there's something else in the list, we bind it to X and to Y. And if nothing, we just use the underscore, which is kind of like a throwaway variable. Now, over here, I have X and Y declared. Now, when I first look at the match and case statements, what I didn't know is that a lot of the when you're capturing variables in your case statements, that variable is not limited only to the match block. It actually changes outside of the block as well. So if we were to run this, we're going to see, of course, it's a list with 2 items. And over here, there is 1 and 2. If we were to change this to 3 and 4, we'd get the same thing. But this would get overwritten by the match and case statements. So that's another weird thing in Python that you might want to be wary of. And of course, we don't cover this right yet, but we do plan to add this rule eventually to SonarLint. So you might say, well, that's all great and good. You're writing code, but what if I wanted to have this integrated somewhere else, if I wanted to have this integrated in my build process? So over here, if we go back and we just set all these things back to what they were, I'm really sorry for this second example. I tried it a couple of times and it was working as expected. So over here, we are not going to fix this, and we're not going to fix this either. So what I'm going to do is I'm going to commit this code, and I'm going to commit and push it to my repository. If I go back to Chrome over here, I have something called Sonar Cloud opened up. And what Sonar Cloud does is basically it integrates all the rules that you can find in SonarLint, as well as some other rules that aren't really that haven't been implemented on a linter level. So you need, we have something called the data flow bug detection, which goes into your code a little deeper and tries to understand what it does. So what Sonar Cloud is going to do is tell you, what kind of bugs you're having, the kind of code smells, the vulnerabilities, and the security hotspots. And so if we take an overview of this, we can actually head over to the main branch. We can see what kind of bugs are here. Sorry, this is a wrong one. This is a wrong one too. Oh, here we are. So over here, you want to change this default value to none. So if you integrate Sonar Cloud into your QA process, it can help you detect a lot of the code smells before you get them. Over here as well, we can see the issue that we talked about when you're having something out of scope. And of course, there are some other issues in the code as well. So over here, you can see that there's a code smell. And this is the code smell that you have. Let's see if my latest push changed anything. So as you push your code into Sonar Cloud, this gets automatically scanned and checked. So, and of course, it's free for all open source code. So if you want to add a new project, right now, my current organization, my personal account is linked with Sonar Cloud. And of course, I can add anything, add any particular project, and I can say setup, and then I will have the same situation that I have here with Sonar Cloud. Okay, so what I wanted to say secondly, is a lot of our rules are actually completely available for free, and you can see what these rules are on our rules.sonarsource.com website. You can see what's going on here. So the first example that I showed you folks, we have a default list being created here, why this is non-compliant, what compliant solution would look like, and what a compliant class would look like. So it goes into more depth. And you can see where it's available, whether it's in SonarLint, Sonar Cloud, or SonarQube.
That's great, Nafiul. I know we're coming up close up to time.
Okay. So essentially, that's what I wanted to show you. If you want to learn more about the different rules that I talked about, you can take a look at this blog post. Please take a look at our rules. And eventually, this video will be available on our YouTube site as well. So thank you. Thank you for attending. And going back, I wanted to ask you folks, which Sonar Lint or Sonar Cloud feature did you like the most?
Cool. Thanks, Nafiul. As people fill out that poll, I'm just going to remind everybody that we're open for questions. I know we've been receiving a few, and as we're getting close to time, we will send out the questions and the answers afterwards. And I know, Nafiul, once the poll is closed, I'll put up just a quick note about what's coming up next. But if I may just quickly fire a couple of questions to you real quick. Sure. So how does SonarLint, Sonar Cloud compare to RUF? So
RUF is a very fast linter. What SonarLint and Cloud does is that it does a deeper analysis. So if you think in what RUF has over, say, SonarLint and Cloud is speed, but what SonarLint has is basically depth in terms of rules and also the documentation around them.
Next question, thank you. Next question, I'm going to go real quick, so I'm coming up on time. So does SonarLint work with types?
Yes, it does. It does work with types. And I think you'd probably get better performance and understanding out of types in Sonar Cloud, because that has something called the BDB, the DBD, and that actually tracks the different types and things like that.
Try and squeeze in one more question. Does SonarQube support the latest version of Python?
Yes, it does. Absolutely. 3.10 and 11.
And can SonarQube find security issues related to not sanitized user input?
Yes, it absolutely can. So I think I have an example here. Over here, you can see this is actually one of the vulnerability issues. So you can see here, we're trying to get an argument directly from the request, and this will be triggered as non-compliant code in SonarLint. And no, actually, it will be triggered as non-compliant code in Sonar Cloud. So that's one of the things Sonar Cloud offers over SonarLint.
Cool. Nafiul, thank you so much. I'm sorry to make the questions so fast. There were many more, but we want to respect the time. So thank you to everybody who have posed questions. And we also encourage you to pose those in our community, but we will send out the answers to the ones that we've received. Please do visit sonarsource.com for further information about Clean as You Code. And just a reminder that there will be a survey popping up at the very end to help us improve our next webinar. Thank you, Nafiul. Thank you, everybody, for attending, and see you all soon.